Good evening, Chem Kids. This is an explanation of net ionic equations for Chapter 11, Writing Word Equations. Let's start with a simple equation like chromium 3 chloride reacting with silver nitrate to produce chromium 3 nitrate and silver chloride. The first step is to make our compounds. Chromium 3 chloride is made from chromium with a +3 charge. Remember that the Roman number is the charge of the ion and it's always positive. And chloride comes from chlorine on the periodic table, which is -1. We balance this, the 3 plus and the 1 minus don't cancel out, so we need a 3. And so chromium 3 chloride, the formula is CrCl3. That is this piece right here. Now let's make silver nitrate. Silver nitrate is made from silver ion, which we need to memorize is a +1 charge. And nitrate is one of the polyatomic ions that we agreed we would memorize, and that has a -1 charge. These get together 1 to 1, so silver nitrate is AgNO3. Next is chromium 3 nitrate. Chromium 3 nitrate is made from chromium 3 ion. That's the charge and it's positive. It's a transition metal. And nitrate ion, which is -1. And again, this is not balanced, so we need a 3 here because the 3 and the 1 don't add up to a 0 charge. Therefore, the formula is CrNO3, 3, and that is the formula for chromium 3 nitrate. And finally, silver chloride, which I'll put in green here. Silver chloride is made from silver ion and chlorine, and they get together 1 to 1, so that is AgCl. So here's our 4 pieces. Our 4 pieces are chromium 3 chloride, silver nitrate, chromium 3 nitrate, and silver chloride. We're going to put all those together in an equation. So chromium 3 chloride and silver nitrate make chromium 3 nitrate and silver chloride. The next thing I have to do is I have to make sure that my equation is balanced. I have metals and non-metals in this equation, so I'm going to check the metals first. I have 1 chromium on the reactant side, 1 chromium on the product side, so that's okay. And there is 1 silver and 1 silver, so that's okay. Now I'm going to go to my non-metals. I'm going to start with chlorine. There's 3 chlorines on this side and only 1 chlorine on this side, so I'm going to put a 3 in front of the AgCl. But I just disturbed my metal, the silver, so I'm going to put a 3 in front of this silver here. And everything is balanced because I have 1 chromium on each side. I have 3 chlorines on each side, right here. I have 3 silvers on each side. And you can look at the nitrate 2 ways. You can see that I have 3 groups of nitrate on one side and 3 groups on the other. Or I could split this up separately and say, okay, on either side I have 3 N's and 9 O's. So either way you look at it, you come up with the balancing ratio of 1 to 3 to 1 to 3. All right, now the next thing we have to do is we have to assign states of matter for all of these compounds. Let's clean this up a bit. And let's make this cleaner by writing 1 to 3 to 1 to 3. My states of matter, I'm going to use the solubility rules. This chromium 3 chloride is a chloride, and remember the exceptions to chloride are silver, lead, and mercury, and so chromium with chloride is okay. We're going to go back a little bit to make sure that you heard that correctly. The chromium 3 chloride is a chloride, and it's not with the exceptions of mercury, silver, or lead. So that is aqueous. The silver nitrate is a nitrate, so that is aqueous. The chromium 3 nitrate is a nitrate, and that is aqueous. But the silver chloride is a chloride, but it's with the exception silver, so that is a solid, and that is our precipitate. This is a good time to review the solubility rules. The solubility rules, we've kept them simple. The first one is never hate no one named Kevin. The never hate stands for ammonium ion. No one stands for nitrate ion. Named stands for sodium ion, and Kevin is potassium ion. So all of these ions, if they're in a compound, make everything soluble or aqueous all the time, no exceptions. No exceptions. There's another no exception rule, and that is acetates. The polyatomic ion acetate is CH3COO negative, also written as C2H3O2 negative, either way. And all acetates are soluble all the time, no exceptions. The next rule is for chlorides, and that does have some exceptions. So any compound ending in chlorine is soluble except when it starts with silver, mercury, or lead, which are considered to be the heavy metals. And that's the solubility rules that we're using for our test tomorrow. Now that we've determined that chromium 3 chloride is aqueous, silver nitrate is aqueous, chromium 3 nitrate is aqueous, and silver chloride is a solid, Now we can begin our separations. I'm going to write the equation quickly again so that we have more room. Chromium 3 chloride aqueous, silver nitrate aqueous, going to chromium 3 nitrate aqueous, and silver chloride solid. All right, since chromium 3 chloride, we're going to start with chromium 3 chloride is aqueous, then I'm going to separate it into chromium 3 ion and chloride ion, but there's 3 chloride ions, so I'm going to write 3Cl minus here. Let's not forget to write in our balancing of these equations. So this is a 3 here and a 3 here. This was a 1 to 3 to 1 to 3. Okay. Now I'm going to separate, this is aqueous. Now I'm going to separate the silver nitrate. I'm going to separate that in a different color into silver ion. And there are 3 silver ions and 3 nitrate ions. I'm going to further separate the chromium 3 nitrate into chromium 3 ion, Cr3 plus, and 3 nitrate ions. And then finally, in a different color, I'm going to write the silver chloride, but if you notice this time I am not separating them because they are my precipitate. I'm going to write AQ on all the ions that are soluble. So what I've done is that I have separated the chromium 3 chloride into ions because it was soluble, the silver nitrate into ions because they were soluble, the chromium 3 nitrate into ions because it was soluble, and the only thing I didn't separate was the silver chloride because it's a solid. The next thing we're going to do is we're going to cancel out our spectator ions. The spectator ions are the ions that are the same on both sides. So I'm going to cross out the chromium 3 with the chromium 3. And I'm also going to cancel the 3 nitrates with the 3 nitrates. This is a 3 here. What's left over is Cl minus plus 3Ag going to AgCl, and I'm going to rewrite this, but I'm going to write my positive ion first, which is silver. So my net ionic equation is Ag plus 3Ag pluses, aqueous, plus 3Cl minuses, aqueous, going to 3AgCl solid. If you notice, this is the formation of a precipitate. So if you do your net equations correctly, your net ionic equations correctly, you will always be left with one of the driving forces. The driving forces are the formation of water, the formation of a precipitate, the formation of a gas, and the transfer of electrons. This is clearly an example of the formation of a precipitate. That's what's going on here. Now, if you are asked for the spectator ions, they are the ones that you crossed out. They do not take part in the reaction. They're the ones that stay floating in the water. And the spectator ions are chromium 3 ion and nitrate ion. Now, if you notice, it says 3 nitrate ions, but That's not what we want to write. We don't need the 3. So the spectator is just the 3 nitrate ions. If you were asked to draw what this would look like, here is a beaker. The precipitate is silver chloride. That would be down here at the bottom. This is your precipitate, a solid. Precipitate always settles down to the bottom of the beaker due to gravity. And the ions, the spectator ions that would be floating in the water are chromium-3 and nitrate ion. And remember, there's more than just 2 of those. There are millions and millions and billions of those floating in the water, and they will never meet. They're attracted to each other, but they will never stay together because the water will drive them apart since they're soluble in water. I hope this helps. That reviewed a lot of the material. I'm available by email tonight, and I'll be here in the morning. I will see you tomorrow.